Okay, first part of a two-part lesson today, dividing polynomials by monomials. So we're going to divide two or more terms, your polynomial, by one term, a monomial. Remember, you say how many terms there are, looking at how many plus or minus signs are in between. So here I've got 3 terms on top, here I've got 2 terms on top, and we've got 1 term on the bottom of each of these. So polynomials by monomials. Okay, so when a polynomial is divided by a monomial, every term in the polynomial is divided by that monomial. So here, the 9y is going to get divided by 3, as well as the 12 is going to get divided by 3. So I could write it like this: 9y over 3 plus 12 over 3. And that is the exact same thing as what we've got on top. So we're going to equal here. 9y divided by 3 is 3y, and 12 divided by 3 plus 12 divided by 3 is plus 4. Okay, so I'll leave 2 for you as an example to give that a try. Let's look at a couple of trickier ones down here, I guess. Okay, so here we're dealing with the minus sign, so it's just really important that you remember to apply that minus sign to each one. Okay, so here I'm just going to make sure I'm going to divide out what I've got here. So 27r cubed minus 9r. So 27 divided by minus 9 gives me minus 3. Okay, r cubed divided by r gives me r squared. Okay, so I'll move on to my next term. So minus 18 divided by minus 9 gives me a plus 2. Okay, this 18, you got to really remember that it has that sign that's out in front of it. So minus 18 divided by minus 9 gives me plus 2. And then r squared divided by r gives me r. And here again, the minus goes with 36. So minus 36 divided by minus 9 gives me plus 4. And then r divided by r is just 1. So there's your final answer. Okay, so that's a good start to the dividing. I'm going to leave 4 for you as a little exercise. So that dividing is going to help us out with our next part of the lesson here, which is finding missing factors and greatest common factors. So let's start with something really simple, and something you already know. If I go to solve 4x is equal to 12, everybody in the room knows that I'm going to divide 4 by each side to find that x. So that's going to leave me with x is equal to 3. Now, 4 and x are called factors of 12, and 12 is the product. So the two numbers that multiply up, 4 and x, to give us 12 are the factors, and that 12 is the product of these two numbers. And x can be thought of as a missing factor. Okay, we don't know the 3. Okay, so we don't know it, so it's our missing factor. So what I do is I just divide by the number that I do know of my products, okay, or sorry, of my two factors, and I divide by what I know so I can find the missing one. So let's try a couple of these. So here I want to find my question mark, so I'm just going to divide both sides by 6a squared m and 6a squared m. Okay, so here I'm left with my question mark because this term divided by this term just gives me one question mark. Right? And on this side, I'm just going to divide. So 24 divided by 6 gives me 4. 8 to the 6 divided by 8 to the 2. Okay, remember, when I divide numbers, I subtract their exponents, gives me 8 to the 4. And here, m to the 9 divided by m to the 1 gives me m to the 8. Okay, so go ahead and give number 2 a try there on your own. Okay, so let's try one that's a little trickier. Here we've got 1, 2, 3 products, or factors that multiply to one product. So to find our missing piece, let's put these two factors together. So I'm going to multiply those two together. So it's going to be minus 15. 3 times minus 5 is minus 15. Okay. R times R squared gives me R cubed. And S times S gives me S squared. That times my check mark, or my question mark, is going to give me 45R6 S to the 4. So, just like before, I'm going to divide minus 15R cubed S squared by both sides to isolate my question mark. Okay, and so my question mark, or the missing factor, is going to turn out to be, so 45 divided by minus 15 gives me minus 3. R to the 6 divided by R3 gives me R3, or R cubed. And S to the 4th divided by S to the 2 gives me S squared. Okay? And I'll leave number 4 for you for an exercise. So just pause it now and give that a go. Okay? So now we're getting into classifying our factors. So a greatest common factor is the largest term that divides evenly into a set of terms. So a set of terms means that I'm going to have a list of terms with plus or minus signs in between them. So let's take a little look at what this is all about here. So here's a couple of examples. So find the greatest common factor in each of the following. So I want to find the biggest number that's going to divide evenly into this. So I'm going to split it up into all of its factors. So x to the 5th is 5x's. X times x times x times x times x. And x cubed over here is going to be 3x's multiplied together. So if I take the biggest group of factors that's the same from both, that's my greatest common factor. Okay, so I'm saying here that it's going to be x times x times x, which is x cubed, is my greatest common factor. So if my definition is a greatest common factor is the largest term that divides evenly into a set of terms, okay, that means that I should be able to divide both x to the 5 and x to the 3 by x cubed. And x5 divided by x3 gives me x squared, so that works out pretty slick. And x3 divided by x3 also works out to give me 1. So I've found my greatest common factor, my GCF, is x to the 3. So let's try and do number 6 here. So here I'm going to write out both terms, and I'm going to expand their factors out so it shows all the factors. And what I'm going to do is I'm going to look for the greatest group of x's that I can take out of each and the greatest group of y's that I can take out of each. So here looks like 2 x's I can take out of this one. So that's all I can take out of this one. That's what's common to both terms, is 2 x's, okay, or x squared. Okay, and then this side looks like I can only take out 2 y's from this one. So what's common to each is a group of 2 y's. So my greatest common factor, or my GCF, is going to equal x squared y squared. So it looks like the variable with the lowest exponent, so if I compare these two terms, this was the low exponent for my x's, and this was the lower of exponent for my y's. Looks like the lowest exponent turned out to be the piece that I had to put in my GCF. So the lowest exponent is part of the GCF. So let's take a look at one with an example with an actual constant up in front. So here 16 is the same as, if I break that down into its factors, 16 is the same, well, I know it's 2 times 8, and I know that 8, you guys should know, is 2 times 2 times 2, so 2 times 2 times 2 times 2 gives me 16. Okay, so that's 16 broken down into its prime factors, and then I'm going to have 2 m's there. And 20 is the same as 4 times 5, which I can also break up into 2 times 2 is 4 times 5, and then m times m times m. Okay, so I know that my lowest exponent should be the GCF for my variable. So I'm thinking, does that work out? Yep, I got 2 m's are common to both terms. And here also, looks like 2 2's is common to both terms. So my GCF is going to equal 2 times 2 is 4 m squared. Now let's give that a check here and see if it deals with our definition of a factor and see if they divide evenly. So let's go 16 m squared divided by 4m squared, and that's going to give me, looks like 4, so that's okay, it divides evenly. And 20 m cubed divided by 4m squared, okay, that's going to give me 5. 20 divided by 4 is 5, and then m cubed divided by m squared gives me m. So that divides. So let's give 8 a try. So we'll start the same way. Let's break this constant up. So 56, I know that is the same as 7 times 8. So I can write that as 7 times 2 times 2 times 2 times c cubed times d squared. And 32 is the same as 4 times 8. 4 times 8, which looks like, oh, look at this, 2 times 2 times 2 times 2 times 2. So 5 2's times 2 times 2 times 2 times 2 c cubed e squared. So let's find the common factor for the constant first. So here it looks like I've got 3 2's, and I can also take 3 2's out here. So 2 times 2 times 2, 3 2's is 8. Okay, and here, let's put that. So we're looking for our GCF here, right? So our GCF is equal to, our 3 2's is 8. And now we're just looking for the least exponent for each term for each common variable. So C looks like they're common to each, and there's 3 in each of those. So 8c cubed is going to work. And then for D, I've got 2 D's here, but I don't have any D's over here, so I can't include that into my common factor. And same here, I've got e squared here, but I don't have e squared over here, so it's not common to both terms, so it can't be part of my greatest common factor as well. Okay, so I just dumped the check in here for you, kind of magically. So I'm going to leave this last one as an exercise for you, and here you just have to kind of be aware that there's 3 terms that you're trying to find common pieces to instead of 2. Okay, so give that a go and know how to do some stuff about greatest common factors and dividing. You should be set up for next class. Cheerio.